right, let's talk about these two problems. First one, the one on the left. What do you notice about it? Yes, sir. Both sides are square roots and everything is underneath the radical. So the very first thing we need to do is get rid of those two radicals. Yes, we're going to square both sides, because if you do it to one side, you have to do it to the other side. We square everything, so when everything is under a square root, all that does is cancel the square root. If we have things that are not under a square root, then we would have to take it and square it. So this is going to just get rid of our square root here, and it will get rid of our square root here. So we're going to have 24 minus 2x equals 15 minus x. What would I want to do next? What's my goal? Get x by itself. So we need to get the x's to the same side. They're on two different sides right now. How can I get the x's to the same side? Add it. What do you want me to add? 2x to both sides. It's going to make it cancel on the left. So I'm going to bring down my 24 on the left-hand side. I'm going to bring down my 15. I have negative x plus 2x. What would that give me? What'd you say? 1x. You can write it as 1x or you can write it as just x. You don't have to have the 1 in front of it if it's a 1. What do I need to do now to get the x all alone? Subtract 15 from both sides. What's 24 minus 15? 9. So 9 is equal to x. Before I know whether or not that is valid or extraneous, I have to check it. How do I check it? Substitute 9 in for x in every spot where I see an x in the original problem. So I have the square root of 24 minus 2, and then I'm going to put in a 9 here, equals the square root of 15 minus, and then I put in a 9 here. I am not allowed to cross that equal sign when I'm checking. So sticking just on the left, what could I do? Multiply the negative 2 and the 9. What is negative 2 times 9? Negative 18. What else can I do on the left? Yes, we're going to do 24 minus 18. What is 24 minus 18? 6. So underneath the square root, I have a 6. Do I need to put that in my calculator? No, I just need to make sure that on the other side, I get the exact same thing. On the other side, what can I do here? 15 minus 9. What is 15 minus 9? 6. Is this a valid solution? Yes, these two sides really are equal. So that means this answer is valid. Over on the right-hand side, do I start by squaring both sides? No. What do I have to do before I can square both sides? Like terms, we're gonna, I can't combine these two right here because the negative 4 is under the square root and the plus 8 is not. I heard subtract. We're gonna subtract 8 from both sides. The reason that we're doing that is the first thing we've got to do is to isolate this square root. On the last problem, everything was underneath the square root. And we had 1 on each side, so it was already isolated. What is 17 minus 8? 9. On the right-hand side, do we have any square roots or any x's or anything? On the left-hand side, is everything over there under a square root? Yes. If everything's under the square root, if I have it isolated, then I can use what to get rid of the square root? Squaring exponents. If you do it to one side, got to do it to the other side. On the left, what happens? Yes, the squared and the square root are inverse operations. It's like adding 5 and then subtracting 5. They cancel each other out. The other side is 81 because there's no square root there, so I do take 9 times itself. Add 4 on both sides. What's 81 plus 4?
85.
85, so I have 17x equals 85. Now you get a calculator. What are we going to do? 85 divided by 17. 5. Valid or extraneous?
I'm going to say valid.
Probably, but how do I know?
You have to check.
We have to check it. How do I check it?
You have to plug in 5 racks.
Yes. So I would have 17, and then we're going to plug in the 5 in the place of the x. Minus 4. Over here we have plus 8 equals 17. Do I subtract 8 from both sides when I'm checking? No. We cannot do things to both sides when we're checking. Yes, sir. Multiply the 5 by 17. What is that? 85. So I have 85 minus 4 here. 81. So I have the square root of 81. Square root of 81 is 9. 9 plus 8 is 17. And this whole time on the other side we had a 17. These really are equal. And so this is valid. Nice work, guys. All right. At your spot, you should have had a test review for the Unit 5 test. There are a couple key problems that I want to focus on today. I want to start off by looking at number 3, part B. Number 3, part B. What do they want me to do for both parts of number 3? Find the inverse. I see, yes, we are going to switch it. Looking at this right here, see that inequality? Do I need to do anything with that? Worry about it at all when I'm finding the inverse?
You just have to draw your graph.
That would be useful for my graph. So if I was going to draw a graph, that's where that would come in.
You're not supposed to draw a graph on this one?
Nope.
But that's why they put it there.
They put it there so that you know your inverse, your result, will be what?
Greater than, equal to or greater than x.
Sort of. Yes, but like big idea. I want to make sure that my outcome is a, and then it starts with the letter F. Function. I want to know that my inverse, that my result of doing the switching and isolating y means that my outcome is a function. So do not use to find the inverse. This is here. To make sure that the outcome is a function. Okay, so I heard switching. What are we switching? X and Y. I don't see Y. Yep, we've got function notation. So first thing I'm going to do is get rid of that function notation so that I can switch the X and the Y. What will this look like when I switch the X and the Y? Tell me what to write down.
X equals y squared.
Yes, awesome. I loved the tag team there. That was fantastic. X equals 3y squared minus 10. What next? Add 10 to both sides, because what's the goal in the third step? Isolate y, get y by itself. X plus 10 equals 3y squared. What next? Divide both sides by 3. Oh, I'm sorry, I'm not trying to write small, although you're welcome to come up here. It's much closer and there's nobody up here. I'll move my rear end. We're going to divide both sides by 3. All right, so I would have x plus 10 over 3 equals y squared. Yes, now we're going to do radical over it. I'm going to take the square root of y squared. And what about the left-hand side? X plus 10. Radical goes over the whole thing, the entire fraction. We could break that up and do the square root of the numerator over the square root of the denominator. Does anybody know what the square root of 3 is? Is that a nice, pretty number?
No, it's like 1 point.
1 point, whole bunch of junk, right? It does not simplify, so I don't need to worry about breaking this up then. If it was a number like 9 or 4 down on the bottom, then it might make sense to break it up a little bit. What's going to happen over on the right? Yep. Exponent goes away. I'm going to make this a little bit smaller over here. There we go. After complaints about things being too small, I'm making things smaller. Sorry, guys. So I would have y equals the square root of x plus 10 over 3. Am I done? No. Why not? Yes, we need to do f prime, f with the little -1. We got to name our inverse. F inverse of x. That takes the place of what? Of the y. That takes the place of the y. So I recopy the other side of the equal sign. And now I'm done. I want to do both parts of number 4. I'm picking and choosing some of these, like if there's more than one part, I'm leaving some of them for you guys to do on your own tonight so that you can continue to practice. Any of the ones that I skip entirely, it's because I've picked another problem that's like that somewhere else. Number 4. When you read through that text up at the top, before we even get to part A, what jumps out at you?
N equals A squared.
Yes, we've got an equation there. N equals A square root of 25t. What does the N stand for? The number of units. I'm going to underline that in red. What does the A stand for?
It's the constant.
It's a constant. And what about T? Yep, T is time in hours. All right, so as I read through part A, what information do they give me?
The equation.
We have the equation from up above, but then when I read part A, they give us N. Which part is N? Yeah, 240 units. They give us the time. What is the time? 4 hours. So let's make those substitutions. We're going to put 240 here in the place of the N. Do we have anything to put in the place of the A? No. So I just have to leave it as A because they didn't tell me that. Underneath the square root, I have the 25. And then what are we putting in for T? 4. So do I just write it like this? Parentheses. Why parentheses? What operation are we going to do with it?
Distribution.
Distribution. We're going to multiply those.
I didn't
Yes.
say it right. I didn't say it right.
That's okay. 200. I knew what you meant. 240 is equal to, what can I do? Yeah, I can multiply the 25 and the 4. What is 25 times 4? 100. So underneath the square root, I have a 100. Anybody know what the square root of 100 is? 10. So I have 240 equals A, and then this. So I just do like this.
Parentheses.
Parentheses, because what operation is happening?
Distribution.
Distribution, multiplication. How do I get the A alone? Divide both sides by 10. What is 240 divided by 10?
24.
24.
Not bad.
There's my answer for part A.
That was actually simple.
Good. That's what I like hearing.
Then what does it look like that on the test?
Part B, underlined and in bold, says what?
Use your answer for part A.
Use the answer for part A. So what are we substituting in the place of A?
24.
24. So I have n equals 24. Do I have anything else that I can substitute in? You said the t? What can I put in for t? 6. Why 6? Yeah, it says if she works for 6 hours. So that's what I'm going to put in the place of the t in part B.
Parentheses are?
Yep, parentheses there. What can I do with this? I can multiply 25 and 6 together.
150.
150. I don't have room to work down, so I'm just drawing an arrow here. N is equal to 24 and then square root of 150.
You ran out of room, but we did it.
I did run out of room, but that right-hand side, can I put that in my calculator? Is it only numbers and symbols that are on my calculator on the right-hand side there?
15?
Yeah. You got a square root button on your calculator, right?
Oh, yeah.
So we're going to do 24 times the square root of 150. What do we get? If you're using a cell phone calculator, you do 150, then push the square root button, and then do times 24. If you're using a calculator like one of my yellow calculators, you can put it in just like you see it.
Oh, no. That's what it's right. No.
That's okay. Okay, so you do 150, and then the square root button. Yeah. Now times 24. There you go.
That's not cute. I don't want it.
293.9387 something something something.
You're really going to put that on there?
Did they explain what to do with this though?
No. It's
Read the next to last sentence.
Round the nearest whole number.
Round which way?
To the nearest whole number.
Round down. So what would my answer be? 293. Units. Can anybody think about why I would round down when it's so close to 294?
That's his.
She's at work, right?
Yeah.
When quitting time comes, does she hang around and finish up that last one? No, she saves it for tomorrow.
Yeah, so
She was almost done with it. She only got 293 done and ready to be shipped or ready to be moved on to the next department. She'll have to come in and finish that next one the next day.
like on that paper, she's actually going to have to put how much she did. So it's just like...
Exactly. Exactly. If you say you got 294 done and your boss goes through and counts it and they're like, no, you didn't.
You're right.
Like,
You're
you got 293 done. You're still working on that last one.
You're fired.
Hopefully not. There's a labor shortage right now.
No, everybody's unemployed. Unemployment.
Number 5. We just did ones like this in the bell work, right? Take a couple minutes, and I want you guys to do these two on your own. Check them, and then we'll go over them pretty quickly since we've already talked about ones like this.
I'm going back to my seat.
Okay. Okay. Fine by me.
I don't like your class. I'll be tripping.
Oh, you don't like my class?
Like your actual physical.
Oh, the physical classroom. Okay, I can't argue with you on that. Holy cow.
I'll be tripping.
I'm going to give you guys about 2, maybe 3 minutes. I want you to work through both of these. Mm-hmm. Yes, you may. Mm-hmm. In there. All right, talk to me about part A. What's the first thing you're going to do? Square both sides, yep. That will get rid of our radicals, that's correct. So I would have 3 minus x equals x plus 5. What's the goal? Get x by itself. So I need to get the x's to the same side. How do I do that? I can subtract 3. I would add x to both sides first because I want to get my x's to the same side first. So my focus right now is on the x's. If you subtracted 3 from both sides, that does not mean you're going to get the wrong answer. So I would subtract 5 at this point since my x's are over there on the right. Negative 2 equals 2x. Divide both sides by 2, and that means I get what? Oops. I'm sorry, how much? Negative 1. And then we got to check it. That's correct. And so I would have the square root of 3 minus, and then I put negative 1 in for x. Equals over here, I have the 3, and then plus 5. Oh wait, sorry, negative 1. I don't know. Sorry guys, I don't know where I got that 3 from. Yeah, no, you didn't miss anything. Yeah. That is correct. What is it when I subtract a negative right here? We get a positive, so I have the square root of 3 plus 1. Yep, square root of 4. Do you guys know the square root of 4? 2. What about the other side? Negative 1 plus 5 is 4. Square root of 4? 2. What does that mean? It means that it's valid.
Wait. Oh, so we have to get the same answer both sides.
Yes.
Perfect.
Yep. Next one. Isolate that radical first. So what do I do as my first step? Add 1 to both sides. 7 plus 1? 8. And then I square both sides?
Yes, but do you square the 2, right? Okay, so
Yes, we could do that. Or I could do what else?
square the 8.
I can divide by 2 to get rid of that 2. What you suggested is not wrong. If you squared the 2 and then you squared the other part, you would end up with the same final answer. But I'd like to get rid of that 2 because otherwise, I don't even want to think about having to square other things. So I'm going to get the square root of 7x plus 2 equals what?
4.
Equals 4. What now? Square both sides. On the left, 7x plus 2 equals 16. What after that? Subtract 2 from both
So
sides.
you're going to divide 7 by 14?
There we go. 7x equals 14. Divide both sides by 7.
X equals 2.
X equals 2. And then
Just gotta check.
we got to check it. So 2 square root of 7. I'm going to put 2 in the place of x. Plus 2, and then minus 1 equals 7. I'm not touching that right side at all. So what can I do? I can multiply the 7 and the 2 together. 7 times 2? 14. What else can I do? I can add the 14 and the 2, which would give me 16. What else? Square root of 16 is 4. So that's like 24?
No, parentheses.
Parentheses. Without the parentheses, you really mess yourself up.
I was confused after this. What do you mean 24?
Yep. I'm just like, honestly, I'm repeating things that I see happen on tests because we're going fast. I'm not trying to trick anybody. I'm trying to keep you from making mistakes. 2 times 4 is 8, and 8 minus 1? 7. What did I have on the other side this whole time? 7. These are equal. That makes me happy. That means that this is valid. All right.
So wait,
Mhm.
this test we're gonna have to graph?
No, we will.
Oh.
There's graphing problems.
Do you know around how many?
On the test? 1.
Oh.
B, describe this transformation for me.
It's vertically compressed
Vertically compressed. By how much?
by
Yes. By 0.3. What else?
down 3.
Down 3?
I mean, down 9.
Down 9. And to the left, 7. We have our opposite here. We have our K value here. We have our A value here. B is right here, and B is just a 1. So it didn't do anything, and that's why I didn't describe anything there. Number 7. Carlos worked through this problem, and there's one really important thing that I don't see anywhere in Carlos's work. What do we always do at the end?
Check.
Check. Did Carlos check?
No.
No. Why don't you check his 2 answers? Check Carlos's answers. How did Carlos do? Are either one of these solutions valid? 3 is valid. Let's look at how. Is the -2 valid? No. This one is extraneous. If I take that original problem and I substitute in -2 in the place of the x. All right, hold on. Let me make room here so that I can do both checks at the same time. I put -2 in the place of the x. Underneath my square root, I would have -6 plus 7. Over here, I'm subtracting a negative, so that would be plus 2. -6 plus 7 is 1. So I would have 1 plus 2. 1 plus 2 is what? 3. The other side, though, is a 1. Those are not equal. But if I do the same thing with a 3 in the place of the x, 3 times 3 is 9. What's 9 plus 7? So I have the square root of 16 minus 3. Square root of 16? 4 minus 3 is 1. This one works. The other one didn't. It's mainly those signs you got to watch out for on this one. Be very careful about your signs.
Question.
Yes.
Did you mess up in step 4?
Did he mess up in step 4? No. He did a lot in step 4. So what he did in step 4, he got everything to the other side, so he subtracted 3x from both sides. And then he subtracted 7 from both sides. But then he wrote it down like totally flipped, which is okay. Once you get it set equal to 0, it doesn't matter whether you have your 0 on the left or on the right. When you're moving stuff, you want to be careful about it. All right, I want you guys to flip to the back page. We're going to go look at one of those graphing problems. We want to graph our parent function first. Do you guys remember what's kind of goofy about the table for the parent function on these? The numbers. I can't use my 5 favorites, can I? What can I use? I can use 0, 1, 4, and 9, because what does the parent function say we're going to be doing to all of those x's? What's around the x there in the parent function? A radical, a square root. So I'm going to be taking the square root of all of these. So 0, 1, 2, and 3. 0, 1, 4, 2, and 9, 3. Here's my parent. Please don't forget, guys, on the test, that parent function is worth points. Even if you can't do anything else on the graphing problem, graph the parent. You'll at least get a point. What's the domain for my parent? What are the x's that I'm allowed to use?
0.
I'm allowed to use 0. Is 9 the biggest thing I'm allowed to use? What is the biggest? Infinity. It can keep going on and on and on. My range. What's the smallest output we got for y? 0. Is 3 the largest output that we would ever see? No. That also goes on to infinity. All right, now I've got this transformation here. Can you describe it for me? What's going to happen? What'd you say? Reflect. Reflect over what? The x-axis. What else is going to happen? It's going to go up 2. Anything else? To the right 4. So I'm going to add the h value. I'm going to add the 4 to all of my x's. That'll send it to the right 4. So my new x's here are going to be 4, 5, 8, and 13. What do I do to find my y's?
You multiply by the value plus the k.
Yes, we multiply by our a value. So first I multiply everybody by -1. What will that do to all of my y's? Change it to negative. That's what's going to flip it over upside down. And then we're going to make it go up 2 after that. All right, so I have 0 plus 2, so this is 2. -1, and then I go up 2. 1. -2, and then up 2. 0, and then -3, and then up 2. -1. So 4, 2, that's right on my parent. 5, 1, 8, 0. 13's not on my graph, but he'd be like over here somewhere. What's the smallest x my transformation has? 4. And it keeps getting bigger after that. It's pointing off to the right, so we could pick bigger and bigger x's. On the y values, is 2 the smallest y value I have? It's the biggest, isn't it? When I look at my graph, everything else is underneath. It's below. It's smaller than that. I always start with the smallest thing first, but you said that's not the smallest. What is the smallest thing? -1 is what I see here, but can my x's keep going? What would happen to my y's if my x's kept going? They wouldn't stop getting smaller. So how do I explain that? -infinity. Smallest thing always goes first. What's the biggest y? 2. If it's down like this, if it's been reflected, it's going to be -infinity first, and then up to my k value. That k would be the biggest now instead of the smallest. All right. You guys are going to continue studying for the for the test tomorrow. There's a Canvas review that you guys are going to work on during class tomorrow. I was able to get back into my eye specialist because my eye is doing weird things again. I will not be with you, but I will be available by Canvas, so you can message me. You're going to do the Canvas review. Almost all the questions there are automatically graded, so when you turn it in, it'll tell you whether it's right or wrong.
So you're not gonna be here?
I'm not going to be here tomorrow. I have to go back to the doctor for my eye again.
I hope you get that checked out.
It's you and me, but I'm so over this, it's not even funny. This paper review you're going to turn into me on Thursday. So Canvas review, since I'm not here to give you answers, you can check your answers on that. Because when you submit it, it'll kick it back. Yes, you got it right. No, you got it wrong. I want you guys to work together tomorrow on that. Paper review, you'll turn into me on Thursday. I will post those answers on Canvas so that you can check your work against mine.